This is what the ash collected at the site of the Icelandic volcano looks like. A team of scientists, headed by Christoph Lyons from Dresden's University of Technology, is investigating its chemical composition. They are also studying how the ash melts. The data will help evaluate what happens when the ash is sucked into a jet engine. The research is still in its early stages. One major problem is that the ash particles have sharp edges. They do more damage to the surfaces of the turbine blades than these round grains of sand.
And in addition, if the ash melts when it's in the engine, it forms a molten coating that can damage the turbine blades.
Even before melting can occur, the tiny particles have already left their mark on these engine parts. This may weaken the material to the point where it can harm engine performance. The researchers want to know when damage like this poses a threat to air flight. At a special testing facility at the Brandenburg Technical University in Cottbus, the researchers shoot volcanic ash at the parts under controlled conditions. They can set the size, number, and speed of the particles. The temperature can be adjusted too, up to 800 degrees Celsius. This is one way to model what happens when ash gets sucked into a running jet engine.
We hope that in the upcoming months, or a year and a half at most, our research data will prove helpful in establishing maximum permissible values.
Upper limits on ash concentrations could help decide when to ground aircraft. The resilience of the jets also plays a role. The scientists are developing special coatings to make engines more resistant to ash. Protective films are already used on engine parts, but they're not good enough. That's why a new layering system is being developed in Cottbus, combining the hardness of ceramics with the elasticity of metal. It can consist of as many as 40 microscopically thin layers. The researchers claim this could double or even triple the working life of jet engines. But the system will work only if the layers are applied absolutely uniformly. A technique known as vapor deposition does the trick. In a vacuum chamber, the layers are applied one at a time. The protective coating must be able to withstand temperatures of 1200 degrees Celsius. That's how hot it gets inside a jet engine.
We're not that far along. We can say fairly reliably how these layered systems behave at low temperatures, from room temperature up to 400 degrees, but we haven't tested them at really high temperatures yet.
So pilots will simply have to hope that the skies remain free of volcanic ash, at least for the time being.